This is a stress test of Attractec Jetsuit Air. Jetsuit is a ruggedized fanless enclosure for NVIDIA's Jetson Orin Nano Super Developer Kit. The stress test is intended to check if Jetsuit cools the Jetson properly. It shows that Jetsuit's thermal performance is remarkably good. The dev kit is a capable AI board, but a board without a ruggedized enclosure cannot be deployed effectively in the field. Jetsuit is designed to enable easy and reliable field deployment of the dev kit. Let's take a closer look at Jetsuit. Jetsuit is very compact, measuring just 120 by 85 millimeters. The enclosure is ruggedized all aluminum. Installing the Jetson Orin dev kit in Jetsuit is easy, and all of the dev kit's I/O is made accessible. Jetsuit has plenty of mounting options, including direct mounting, DIN rail mounting, and VISA mounting. It even has a unique cable retention mechanism called Stay Plugged. Now let's focus on the most important feature of Jetsuit, its cooling. Jetsuit is passively cooled, having no fan and no vents. Internally, the CPU is coupled to a large copper heat plate and a shaped heat pipe for spreading the heat over the top cover. As you can see, Jetson reports 0 revolutions per minute in the absence of a system fan, but this does not affect operation as long as the Jetson is cooled properly. Can a small fanless enclosure cope with the high power of the Orin Nano Super? Let's find out. For the stress test, Jetson Orin Nano 8GB was installed with Jetpack 6.2, configured to the new Power Mode Max and Super. CPU and GPU clocks were set to maximum frequency using Jetson Clocks command. CPU load was set to maximum on all 6 cores using Stress NG tool. GPU load was set to maximum using CUDA N-body sample with 30K bodies. Interestingly, power is increased when the N-body window is not shown. System was running with this combined loads for 2 hours to ensure temperature and power are stable before taking measurements. Now, let's inspect the measured power of the Jetson Orin Nano Super under this synthetic full load. Jetson Power GUI reported power of about 20 watts for the Jetson Nano module. Power at the wall was 25.5 watts. Power readings are in good agreement considering the extra power of Jetsuit's NVMe, Wi-Fi, DevKit circuits, and PSU losses. So the total power inside Jetsuit was about 23 to 24 watts. We can see that Jetson power was nearly constant throughout the test. And now let's look at the temperatures. Ambient temperature during the stress test was 26 degrees Celsius. Jetsuit's temperature was rising gradually for the first 20 minutes of the stress test. Later, temperature was stable with no reduction in system power. To ensure reliable temperature reading, measurement took place after 2 hours of stress testing at full power. T-junction never exceeded 70 degrees Celsius throughout the test. So let's summarize what can be learned from this test. We can see that the compact and fanless Jetsuit can effectively cool the Jetson Nano Orin Super, even under maximum load. While the dev kit is rated for max ambient of only 35 degrees Celsius, the large thermal headroom of Jetsuit indicates it can work reliably at a much higher ambient temperature. Worth noting that some fanless enclosures require airflow to support elevated ambient temperatures, but with Jetsuit, forced airflow is not required. Finding the maximum ambient temperature would require more testing to see at which junction temperature Jetson begins throttling, and what is the power and performance profile once it does. But if Jetson thermal and power management is as good as in other NVIDIA products, full industrial temperature range using Jetsuit may be within reach.
Thanks for watching. Please feel welcome to leave us a comment. If you wish to try Jetsuit, please visit jetsuit-ai.com.